Hello, for this video, we will solve this problem. What is the maximum temperature that can be reached by the combustion of methane with 20% excess air? Both methane and air enter the burner at 25 degrees Celsius. Assume complete combustion. So this maximum temperature that can be reached, assuming na there's na perfectly insulated yung reactor, this is also called the adiabatic flame temperature. I already wrote the balanced combustion reaction for methane. Okay. And so the first step that we need to do is to make a hypothetical path. A hypothetical path of the combustion reaction. So let's say ito yung reactants natin. Reactants at sinabi ba na kung ano? At 25 degrees Celsius. Okay. So let's say 298 Kelvin. Yan. Let's assume na basis natin ay basis is 1 mole of methane. So if yun yung basis natin, 1 mole of methane, 1 mole of methane yung papasok dyan. Hindi natin pa alam yung mole ng O2. Okay? And then, may air, since air, kasama dun yung O2 and meron ding N2. Now, binigay sa problem na meron kang excess na O2. Okay? By the way, mali pala yung balance reaction. This should be 2. Yan. CH4, 2O2, CO2, okay? Incomplete combustion pala yung kanina. So, ang sinabi is complete combustion. Assume complete combustion. So, this is the balance equation for the complete combustion of methane. Tama ba? Balance na. And ito ay water. Okay? So, ibang problem pala yung sinulat ko kanina. Okay. So, CH4, 2O2, CO2, at saka water. Now, hindi natin pa alam yung reactants na O2 at N2 na pumasok, pero given tayo ng percent excess O2. So, let's begin with the CO2. If 1 mole yung CH4 or methane natin, ang CO2 natin ay 2 moles of O2 kasi base lang yun sa sa combustion reaction, diba? Yan. Now, let's calculate for the excess O2. Sabi ay times 20%. So, 0.2 times 2 is 0.4 mole O2. Okay? Now, how about, so, ang pumasok talaga yung actual na O2 na pumasok. Sum lang yan ng CO2 tsaka excess O2. So, that's 2.4 mole O2. How about the N2? So, N2, you just multiply the actual O2 na 2.4 times yung molar ratio ng N2 and O2 sa air, which is 79 moles ang N2 for every 21 moles ng O2 na papasok. So, that's 9.03 mole ng N2. So, update na natin yung yung diagram. Okay, reactants, 9.03. Saan na ba yan? Diba? Hindi ito yung ginagamit ko. So, yun yung papasok. Now, yung sa actual process, lalabas yung products, okay? Lalabas siya na at a certain temperature na hindi natin alam. Yun yung hinahanap natin, okay? Pero lista natin yung products na yon. Ano ba yung mga products ng combustion, di ba? We have CO2, we have H2O, and then meron tayo nung excess O2 yung di nag-react, at saka meron tayong N2 kasi hindi naman siya part ng combustion reaction. So, using the balance equation, since 1 mole, tas complete combustion daw siya, since 1 mole ng methane pumasok, based sa stoichiometry, 1 mole din ng CO2, diba? CO2 yung lalabas, so 1 mole dyan. And then, based sa stoichiometry, 2 moles ng O2 yung lalabas. Ilang moles ng O2 yung lalabas? Of course, yun lang hindi nag-react kasi yung 0.4 yung sa excess lang. Kasi yung 2 dun sa 2.4 ay na-consume dun sa combustion reaction. How about yung sa N2? Hindi lalabas lahat ng N2. Yan, dito lalabas siya lahat kasi hindi naman siya na-consume sa reaction. Okay? So, lalabas yan lahat. Sa totoo lang, 'di ba, yung totoong past ay pag ganun siya, from 298 to this unknown temperature, to TP. Pero, hindi natin masosolve yun sa that way. So, kailangan natin gumawa ng hypothetical path wherein meron tayong products na 298 dito. Okay, gawa tayo ng hypothetical path. Okay, the dash line. Okay. Tapos, from 298, i-hit natin yung products to the TP. Okay? Na yun yung unknown. So, madali na siyang compute this way. Bakit? Kasi, we can just use our equations for calculating the heat of reactions at standard. Diba? At standard conditions. Then, dito, sensible heat na lang yung kailangan. Okay? Sensible heat. So, basically, we just need to solve yung 298 na standard heat of reaction plus yung delta, yung sensible heat para ma-solve ngayon yung delta HT natin. Diba? Parang technique. So, what's the first step? Kailangan natin ng mga heats of reaction. So, dito natin makukuha yan. Sa ating favorite na book, si Smith and Ness. Ayan, carbon dioxide, nakalista dyan. Diba? Tapos, yung water nasa baba, na gas. Okay, so ito yung gagamitin. Yung gaseous form. Ayan, ito. And then yung methane. Sana si methane. Ito, methane. Yun. So, with that, sulat natin yung standard heat of reaction. Diretso ko na, no? But, basically, I just got these values from yung references. Okay, so this is for CO2. This one is for CO2. This is H2O, and this is for methane. Ayan. So, multiplied by 2 yung H2O. So, products minus reactants. Okay? So, masasolve mo dyan na standard heat of reaction ay yan. So, the next thing na isasolve natin is yung unknown, yung sensible heat. Kaso, hindi siya basta-basta na, diba? Masasolve mo lang ng directly. Kasi, yung sensible heat natin ay dependent sa, yung CP natin ay dependent sa temperature. Okay, so ang gagawin natin, gagamitin natin yung equation na yung CP ng products, same products yung itataas natin. Okay, is summation siya ng moles ng product times yung CP nung kada species. So, I would refer to the species. So, the best way to do this is to make a table. Okay, so, let's list down yung mga species sa product. Okay. Yung number of moles. So, yan yung number of moles. Dun, ito yan. Sa product. Teka. Ito lang yon sinulat ko. Number of moles. And then, isusulat mo ngayon yung coefficients A, B, C, D. So, ano ba itong A, B, C, D? Remember yung sa sensible heat natin. Diba, ganito tayo mag-calculate. We use this equation, ginagamit natin yung A, B, C, D. Okay? Nagaling din sa Smith and Boles. So, kakopyahin ko lang yung mga parameters na to, okay, yung constants na to from Smith and Boles for the different species. Okay? Yan, kinokopya ko lang yung mga values nila, pero makukuha mo to sa Smith and Boles. Ano ko lang to. Maingay. Okay, so copyahin lang natin. 0.040 times 10 to the 5, negative 10. And the next step is to, we get the sum. Okay, diba? We get the sum multiplied by their corresponding, don't forget you need to multiply by their corresponding moles. Okay? Number of moles. So, 43.471 9 point 9 point okay. So, ang next is, diba, we use the equation ng CP. So, do you remember? Yung CP, transposing yung R sa kabilang side. A CT squared negative 2, diba? Pero wala kasing C. Yan, okay. So, basically, input mo lang lahat ng constants dito. Then, integrate. Okay. So, delta HP is, diba, CPDT? So, that's R times yung constants. T plus 0 yung CT. So, minus siya. Minus the 0 to. So, minus .645 times 10 to the 5. Okay. Ito, negative 2. Okay. And then, integrate from 298 Kelvin. Tapos, this unknown temperature na hindi natin alam. So, dalawa na tuloy yung natin, yung TP tsaka yung delta HP. Pero, unknown nga ba yun? Yung saan natin makukuha siya? Okay. Yung delta HP. Doon sa okay. Sinolve natin siya kanina. Yung delta HP mo actually is equal siya doon sa dito. So, bakit? Kasi remember, ano tayo, adiabatic flame temp. Okay? So, sa adiabatic flame temp kasi, Q equal to 0. So, this is, yung delta H mo equal to 0 siya. So, therefore, yung delta H298 mo ay equal to delta HP. Yun. So, remember that for adiabatic flame temperature. Ganun siya. Kaya, yung delta HP mo ngayon dito, equal siya do sa sinolve natin na 802. Pero, since negative siya nito, kasi tinranspose mo sa kabilang side. So, equate natin yon. Malinaw ba yon? Oo. Adiabatic flame temp na pala ito. So, 802,000 625. Nakuha? Ulit. So, normally, if hindi adiabatic flame temp, diba? Ito yung way ng pagsasolve natin. Delta HT equal siya dun sa dalawang path. Pero, kasi pag sinabing adiabatic, Q equal to 0, and then, so that means, if constant pressure, diba, Q is equal to delta H, delta H equal to Q is equal to 0. So, this one is 0. Therefore, yung delta H at 298 natin, equal na siya sa negative ng delta HP na to. Okay, nakuha? Yan. Ito at saka ito. Equal na sila. Yan. Kaya, yung nakuha dito na 802,000, in-equate mo na siya dito sa delta HP. Tapos, isa na lang yung unknown mo, which is yung boundary ng integral. So, you can use a solver program to do that, or pwedeng mong i-solve manually by by integrating ito using integrals to para mailabas mo yung TP. Okay? Pero ang masasolve mo dito ay na TP. Okay? So, isa na lang unknown, which is yung TP. Ang ginamit ko ay in-integrate ko siya. Tapos, nilabas ko yung TP. 2067 Kelvin. Yan. Yan ang final answer.